Tesla just dropped a bombshell that could destroy the entire car industry, and it costs less than $10,000. In this video, you'll discover how Tesla's revolutionary Model 2 uses groundbreaking technology to solve the biggest problems plaguing modern cars: planned obsolescence, sky-high maintenance costs, and outdated engineering. By the end, you'll understand why this $9,797 electric vehicle isn't just affordable transportation. It's a strategic weapon designed to reshape how we think about car ownership forever. Welcome to Tesla Torch, where we break down the innovations that are electrifying the future. If you're ready to see how Tesla is quietly starting a revolution, smash that like button and subscribe for more cutting-edge automotive insights. Let me paint you a picture of what's wrong with the car in your driveway right now. Under the hood, there are over 100 separate electronic control units, all trying to talk to each other through something called a CAN bus system. Think of it like having 100 different managers in a company, each responsible for one tiny task. One controls your headlights, another manages your windshield wipers, and yet another handles your air conditioning. This sounds organized, but it's actually a disaster waiting to happen. Each of these units is a potential failure point. When one fails, it can bring down multiple systems with it. Your car becomes harder to diagnose, more expensive to repair, and frankly, it feels like it was designed to break down just outside of warranty. And here's the kicker: this complexity is costing you a fortune. According to 8AA, the average gas-powered vehicle costs about 9 cents per mile just in maintenance and repairs. That's roughly $1,550 every single year if you drive 15,000 miles. Over a decade, you're looking at more than $10,000 just to keep your car running. And that's before you even think about gas prices, oil changes, transmission fluid, timing belts, brake repairs. It never ends. The automotive industry has perfected the art of planned obsolescence, making cars that feel outdated the moment they leave the dealership lot. But Tesla saw this broken system and decided to completely reimagine what a car could be. Enter the Model 2, and everything changes. Instead of 100 separate electronic brains scattered throughout the vehicle, Tesla built one incredibly powerful central computer powered by their Dojo inference engine. We're talking about 10 teraflops of computing power. That's more processing capability than most data centers had just a few years ago. This single brain controls everything: your acceleration, braking, climate control, entertainment system, even your door locks. But here's where it gets really clever. Instead of running cables to every corner of the car like traditional vehicles, Tesla uses what they call zonal controllers. Think of these as regional managers, one for the front of the car, one for the center, and one for the rear. This approach has slashed the internal wiring by an incredible 87%. Where older car designs used over 1.5 kilometers of cable snaking through the vehicle, the Model 2 uses under 300 meters. Less wiring means less weight, lower costs, fewer things that can go wrong, and easier recycling when the car eventually reaches end of life. But the real magic happens when something does go wrong. Remember those 100 separate modules in traditional cars? When one fails, you're often looking at a trip to the dealer, expensive diagnostics, and parts that might take weeks to arrive. The Model 2's centralized system can actually heal itself. It constantly monitors every component, and when it detects an issue, it can isolate the problem, reset components, or reroute functions automatically. Many problems that would have sent you to a repair shop can now be fixed with an over-the-air software update while you sleep. Early testing shows a 32% reduction in electronic failures compared to Tesla's previous models. The system can even predict when components are starting to wear out, scheduling maintenance before you're stranded on the roadside. And there's a performance benefit too. Traditional car systems suffer from communication delays as signals bounce between all those separate modules. Tesla's zonal design creates much shorter communication paths, allowing commands to execute up to 20 times faster. When you're talking about emergency braking or obstacle detection, those milliseconds can literally be the difference between life and death. Now, let's talk about something that sounds boring but is absolutely critical: thermal management. Electric vehicles generate a lot of heat, especially in the battery pack and motors. Too much heat kills performance and dramatically shortens the lifespan of expensive components. Most EVs use simple cooling loops, kind of like the radiator in a traditional car, but Tesla has engineered something far more sophisticated. The Model 2 has over 50 high-precision temperature sensors scattered throughout the battery pack, power inverters, and motors. These sensors provide feedback multiple times per second to a control algorithm that directs coolant flow exactly where it's needed most. Instead of cooling the entire system uniformly, the Model 2 can target hotspots with surgical precision using flexible liquid channels and smart flow valves. The result? Tesla can maintain operating temperatures within just 1 degree Celsius of the optimal 37-degree target, even when the outside temperature ranges from -20 degrees to over 45 degrees Celsius. This precision is crucial because the Model 2's aluminum-ion battery pack performs best between 35 and 40 degrees Celsius. Tesla's testing showed that after more than 1,000 charge and discharge cycles in varying temperatures, battery modules showed less than a 2.8-degree drop in performance. This translates to a 17% increase in battery longevity compared to simpler cooling systems. That's approximately 60,000 extra kilometers of driving range for the average American driver. The dual motor inverters, which heat up rapidly during acceleration and regenerative braking, are cooled using direct contact liquid interfaces and carbon composite casings. These materials transfer heat more effectively than aluminum, reducing inverter heat load by 14% on highways and up to 22% in stop-and-go city driving. The auxiliary power needed just to keep everything cool drops by up to 18%, which translates into an extra 11 to 17 miles of driving range per charge. Here's something most people never think about until it's too late: dirty sensors. The Model 2's advanced driver assistance systems rely on cameras and ultrasonic sensors to see the road, detect obstacles, and keep you in your lane. But what happens when these sensors get covered with dust, snow, rain, or bug splatter? In most cars, your safety features just stop working until you manually clean them. Tesla solved this with an integrated self-cleaning system that combines mechanical engineering with artificial intelligence. Compressed air is delivered through micro nozzles positioned near each camera and sensor. But the system doesn't just blast air constantly. That would be wasteful and noisy. Instead, it uses a dual detection system to know exactly when cleaning is needed. A light sensor monitors how much light is reflecting off each camera lens, while AI algorithms analyze the video feeds in real time, looking for distortions or blockages. When signal clarity drops by 12 to 18%, the system releases a brief but powerful air burst to clear away debris. Tesla validated this system through 68 different environmental tests: dust tunnels, fog chambers, rain simulations, and snow spray events that would make a blizzard look mild. The cleaning process restored an average of 96.4% of sensor visibility, ensuring your safety systems work reliably even in severe weather. At highway speeds, even a brief loss of visibility can translate into several meters of blind travel distance, making this rapid response system potentially life-saving. Now, let's talk about something that will blow your mind: the car's structure itself. Traditional vehicles are assembled from dozens or even hundreds of separate steel pieces, all welded together. It's labor-intensive, creates weak points at every joint, and makes repairs complicated and expensive. Tesla threw out this century-old approach entirely. The Model 2 eliminates dozens of welded components in favor of large, single-piece subframes made using aluminum die casting. Tesla's massive 9,000-ton gigapress can cast the entire rear or front underbody section in one shot. But this isn't just about manufacturing efficiency. The design itself is revolutionary. Tesla's engineers took inspiration from one of nature's most perfect structures: the eggshell. An eggshell can support tremendous weight relative to its thickness because it distributes external forces across curved surfaces to protect what's inside. The Model 2's frame uses the same principle, with deformable aluminum alloys on the outer sections that absorb impact energy, while the inner structure uses magnesium-aluminum blends and boron steel beams for maximum strength. Computer simulations show a 31% reduction in peak impact stress compared to traditional steel-framed vehicles, dramatically improving passenger safety during collisions. But here's the really clever part. The core structure remains intact during most accidents, allowing damaged outer panels to be replaced without compromising the vehicle's integrity. This reduces repair times by up to 40% and keeps insurance costs lower. The single-piece casting also increases torsional stiffness by 22%. That might sound like engineering jargon, but what it means is less chassis flex, more precise steering, and a quieter cabin with minimal vibration. Your Model 2 will feel solid and responsive in ways that traditional cars simply cannot match. But Tesla didn't stop there. In most electric vehicles, the battery pack is essentially a heavy, expensive piece of luggage bolted to the bottom of the car. It serves one purpose: storing energy. Tesla decided that was wasteful, so in the Model 2, the battery pack is actually part of the car's structure. The aluminum ion cells are arranged in a honeycomb pattern and bonded with fire-resistant epoxy, forming what's essentially a monolithic slab with incredible shear strength and even force distribution. This structural battery pack isn't just storing energy, it's helping to hold the entire car together. This approach increases torsional rigidity from 28,000 to 36,000 Newton meters per degree, a 29% improvement that enhances steering precision and body stability. The structural battery can absorb more than 80 kilonewtons of localized impact force without deforming, exceeding federal safety requirements by over 40%. Laboratory testing confirmed it can maintain integrity under both vertical crush and side impact conditions. By eliminating the need for separate steel housings and mounting hardware, Tesla cuts overall chassis weight by 14%, contributing an additional 27 to 32 miles of range per charge. The battery is embedded directly into the vehicle floor during manufacturing, which reduces vibration and thermal stress while ensuring consistent thermal contact across all modules. Tesla projects the battery lifespan will exceed 300,000 miles with less than 10% capacity loss under average US driving conditions. And because the battery is installed during the HASI's casting process, there are fewer fasteners and alignment steps, shortening assembly time per unit by over 10%. This manufacturing efficiency helps Tesla scale Model 2 production while keeping costs incredibly low. Here's where Tesla's strategy gets really interesting. Most vehicles feel outdated as soon as they leave the dealership. The infotainment system looks ancient compared to your phone. The driving features never improve. And within a few years, you're already thinking about your next car. Tesla completely flipped this model. The Model 2 receives over-the-air software updates via Wi-Fi or cellular connection, allowing capabilities to improve long after you buy the car. We're not talking about minor bug fixes. These are substantial improvements in performance, new user interface features, enhanced safety systems, and additional entertainment options. Your Model 2 becomes a dynamic platform that evolves over time rather than a static product that slowly becomes obsolete. This approach defies the entire concept of planned obsolescence that the automotive industry has relied on for decades. Instead of needing to trade in for the latest model to access new functionality, your Model 2 continues getting better, often in ways you didn't expect. And let's talk numbers. As an electric vehicle, the Model 2 eliminates most of the recurring expenses that drain your wallet with traditional cars. No more oil changes, no transmission fluid, no timing belts, no spark plugs, no exhaust system repairs. Maintenance is limited primarily to tires, cabin air filters, and occasionally brake pads, though Tesla's regenerative braking system means even brake wear is minimal. Over a 10-year period, a Model 2 owner could save more than $10,000 in maintenance and fuel costs compared to a compact gasoline vehicle. That's not including the time saved. No more Saturday mornings spent at quick lube shops or waiting at the dealership service department. While major automakers struggle with the economics of producing affordable electric vehicles, Tesla has completely re-engineered its manufacturing ecosystem for efficiency and scalability. Vertical integration means they control every aspect of production, from battery cells to software development. The gigacasting technology we discussed replaces hundreds of welded components with single cast structures, dramatically reducing assembly complexity and labor time. Tesla's in-house software coordinates supply chain operations and factory workflows, bypassing the delays and inefficiencies that plague traditional automakers who rely on hundreds of different suppliers. The upcoming Giga Mexico facility and optimized production lines at Giga Texas are designed specifically to manufacture the Model 2 at unprecedented scale and efficiency. This creates a pricing advantage that legacy car manufacturers simply cannot match without completely restructuring their operations, a process that would take years and cost billions. Tesla is forcing an entire industry to innovate or risk becoming irrelevant. The Model 2 is more than just an affordable electric car. It's a strategic weapon deployed to disrupt the entire automotive landscape. Every design decision, every manufacturing innovation, and certainly that $9,797 price point reflects Tesla's deeper intent to outlast, outsmart, and outmaneuver the established players who have dominated this industry for over a century. Unlike traditional industry battles fought with marketing campaigns and flashy reveals, this revolution is happening quietly through software updates and structural efficiency improvements that most people will never see but will definitely feel. Tesla has redefined what value means in the automotive world. They've dismantled assumptions about car ownership that have existed for generations and put genuinely cutting-edge technology within reach of millions of ordinary Americans. With the Model 2, you're not just buying transportation, you're buying financial freedom from the endless cycle of maintenance and fuel costs. The innovations we've discussed today, the self-healing electronics, adaptive thermal management, self-cleaning sensors, eggshell-inspired structural frame, and integrated battery pack. These aren't just cool features. They're setting new standards for durability, safety, and efficiency that will force every other automaker to adapt or fade away. As Tesla scales up Model 2 production over the next few years, these technologies will become the new baseline expectations for what a car should be. The automotive world is about to change forever, not with fanfare and flashy advertising, but with the quiet certainty of innovation that actually works and lasts. The future of transportation has arrived, and it costs less than $10,000. The question isn't whether you'll drive one of these Revolut, Ionari vehicles, but simply when you'll make the switch. If this video opened your eyes to what's really happening in the automotive industry, hit that like button and subscribe to Tesla Torch for more deep dives into the innovations that are reshaping our world. What do you think about Tesla's strategy? Let us know in the comments below, and we'll see you in the next video.